Now, for the results, this section shows the impact of climate change on the baseline supermarkets in the 6 locations in 2020 and 2050, and that if nothing changes forward. The graph presents information divided into heating, cooling from HVAC, interior lighting, interior equipment, fans, pumps, water systems, and refrigeration. It is worth noting that space cooling was negligible because the supermarket had open-fronted chilled cabinets. So as a result, the cold air from the cabinets was naturally cooling the aisles, significantly reducing the need for cooling, mechanical cooling. Modeling showed that climate change had positive and negative effects on energy use depending on the location. It increased energy consumption in France, Poland, and the UK, but decreased it in Italy, Lithuania, and Norway. However, despite all these variations, the overall differences in energy consumption between 2020 and 2050 were small, and these were less than 2%. The low impact of increasing climatic temperature was due to a balance between the heating and the cooling demands of the supermarket. In other words, as climatic temperature increased, there was less demand for heating, but this was balanced by the increased demand for refrigeration. Therefore, climate change had little impact on energy use across all 6 locations between 2020 and 2050. However, we must bear in mind and still consider resilience to extreme weather events that may overload the refrigeration system. This slide shows how carbon emissions change under baseline conditions when the EGCI decarbonizes. As shown in this graph, the store in Poland had the highest carbon emissions up to 2050, reaching 126.1 tons of CO2 equivalent per year, though the trend suggests a continued decline beyond this period. In London, despite the EGCI dropping to nearly zero, which was 0.003 kilograms of CO2 equivalent per kilowatt hour, this was by 2050, the carbon emissions remained at 41.5 and did not decarbonize more. And this was because the store was still heated at that time by natural gas. In Paris, where electric resistance heating was still used, emissions reached 17 tons of CO2 equivalent by 2050 due to the EGCI still being 0.023 kilograms of CO2 equivalent per kilowatt hour. In Lithuania, where heating was nearly zero, with EGCI 0.004 by 2050, emissions nearly were zero at 2.7 tons of CO2 equivalent. Finally, for Norway and Italy, Norway had already a low CO2 emissions in 2020 at 5.3 tons of CO2 equivalent, so they are really expected to be near zero by 2050. For Italy, it was already high in 2020 at 152.1 tons of CO2 equivalent. We didn't have any future EGCI data, but these are expected to decrease by 2050. So now, however, although reaching carbon reduction targets at specified times between 2020 and 2050 is important, it is equally important, or not more, to consider the total carbon emitted over a period of time. That is why, by integrating the fourth order polynomial equations representing the CO2 emission curves from this graph, the total carbon emissions between 2020 and 2050 were then calculated for the locations. This resulted in accumulated emissions of 7,207 tons of CO2 equivalent for Poland, 2,759 for Lithuania, 2,090 for the UK, and 835 for France. So Poland had the highest accumulated emissions between 2020 and 2050, and France had the lowest. Now, let's take a look at how energy saving strategy performed when applied individually and then combined across all 6 locations. This chart shows the impact of strategies applied on the energy consumption in 2020. Strategy 1, which adjusted HVAC deadband temperature by 2K, offered relatively small savings, between 3 to 7%. These savings were higher in location using gas or electric resistive heating, like the UK, France, Italy, and Poland. And these were lower in Norway and Lithuania, where air source heat pumps were in use. This was because of the efficiency of the air source heat pumps, which has a nominal COP of 2.75, versus electrical resistive heating with an efficiency of 1, and natural gas with an efficiency of 0.8. Strategy 2 involved adding doors to chilled cabinets, and it had a bigger impact, cutting energy use by 18 to 29%. By reducing both refrigeration and heating needs, this strategy especially benefited stores with natural gas or electrical resistive heating, like France, Italy, Poland, and the UK, as explained earlier. And again, countries with air source heat pumps, like Lithuania and Norway, saw smaller gains due to the greater efficiency of air source heat pumps. For strategy 3, installing air source heat pumps to the locations except Lithuania and Norway due to their baseline being already air source heat pump led to energy savings between 12 to 21%. We need to note that Poland saw the largest benefit due to its cold climate and high heating demand compared to the other 3 locations where this strategy was applied. Rome, at the other hand, where heating was very low compared to the other locations, saw the smallest energy reductions. For strategy 4, it used refrigeration cabinets that consumed 20% less energy. However, since refrigeration only makes up a portion of the store's total energy use, the overall savings across all the locations was only between 6 to 8%. And the biggest benefit was seen in Italy, as it had the highest refrigeration consumption due to it being the hottest location, and the lowest were in Poland. For strategy 5, adding solar PV panels was the most effective strategy individually. Energy savings ranged between 38 to 63%, and this was depending on the location. For example, Italy, with the highest solar exposure, achieved the highest energy savings, while Norway, with the least, had the lowest energy savings. Now, finally, the combination of all the previous strategies resulted in overall energy savings of 69 to 94%, and the highest savings were achieved in Italy, primarily due to the solar panels explained earlier, and the least in Norway, also due to the solar panels having the least impact. In the other locations, energy savings were closed, ranging between 74 and 78%. This shows that the outcomes really vary by location, by EGCI, and also by the baseline scenarios assumptions.